So, now see parallel combination of two cells. Suppose you have got the cell here, the first one having the EMF and internal resistance R1, second cell also have EMF and internal resistance R2. These 2 point A and B are the common points. Current I1 is coming from here, current I2 is coming from out here, and the total current is here I. Now, here we can write VA minus VB is equal to V is equal to EMF of the first one minus I1 R1. Similarly, we can write for the second one V is equal to EMF of the second minus I2 R2. We can solve this one and we can write I1 R1 is equal to here EMF of the first minus V. So, we can write I1 is equal to EMF of the first minus V upon R1. Similarly, we can write I2 is equal to EMF of the second minus V upon R2. So, these are the I1 and I2. Now, we can get the total current. We can just add these two currents and we will be getting I is equal to I1 plus I2, and then we can write I is equal to EMF of the first minus this V upon R1 plus EMF of the second minus V upon R2. Now, we can solve this equation. So, when we solve this equation, we will be getting I is equal to this one R1 plus EMF of the second upon R2 minus V into 1 upon R1 plus 1 upon R2. So, we can solve this. When we solve this we take to this side, V into here R1 plus R2 upon R1 R2 is equal to EMF of the first one R2 plus TM of the second one R1 divided by R1 R2 minus I here. So, we can take this to this side. So, we will be getting V is equal to this R2 plus EMF of the second R1 upon R1 plus R2 minus I R1 R2 upon R1 plus R2. So, this is the expression here we have got for the total potential difference between A and B. This quantity is here equivalent EMF and this is here for the equivalent resistance. So, we can write here for the equivalent EMF and equivalent resistance. So, we can write here E equivalent minus I R equivalent. So, from here we can take E equivalent is this much and R equivalent is this much.